Section 7.3, the slope of a line. Slope of a line is, we're talking about the steepness of that line. And to find that slope, we're looking at the change in y. So how does the value of y change? Is it increasing or decreasing, right? Is the line going up or down? Over the change of x, over our change in x. This is also sometimes called our change in our rise over the change in our run, because think of, we run on a flat surface, but our change in our rise is that flat surface increasing? Are we going uphill or are we running downhill? Slope of any non-vertical line contains points x and y. We have points on our line, and we can find two different points on that line, and we can label those points as x1, y1. And the second point, we can just put a little subscript there of a 2 value. So that way we can understand the difference between our first point and our second point. And all we're doing is we're taking our values for y and we're subtracting them, making sure that we're keeping the same order, 2 minus 1. And in the denominator, I'm doing x2 minus x1. So whatever these values were, I'm just subtracting them to find the slope, the change in height of that line. Here's an example. Here's 2 points. I want to find the slope represented with the variable m. And to do that, I would assign whether this is x1, y1 or x2, y2. And in this case, this example has labeled the first point as the 2. And I know that because the 6 is listed first, and that was listed as y2. So if I did 6 minus 2, subtract my y's, over 3 minus 1, subtract my x's in the same order, I would end up with 4 over 2, which can simplify. They're both greatest common factor of 2. 2 over 1, and 2 divided by 1 can even simplify further to say the slope is 2. Either way, if you said the slope is 2 or the slope is 2 over 1, you are correct. Even saying the slope is 4 over 2 would be correct, it's just not in most simplified form. So that means the slope goes rise is 2 for every 1, up 2 over 1, up 2 over 1, and our slope gives us a positive line that's increasing. So slopes can be positive, slopes can be negative. Slopes going positive, if we're reading the graph from left to right, that means the line is increasing, it's going up. If I'm saying the slope is negative and I'm reading the graph from left to right, like we read a book, the slope is going down, so that would be called a negative slope. Slopes can also be 0 if we're talking about a horizontal line, and that is because why? When I graph this point, I said, how far over x am I going? X is 0, y is 2. So the slope is 0 because x was 0. This is a horizontal line. It is staying flat. A vertical line, any vertical line we say has an undefined slope because the line is not increasing nor decreasing, nor is it 0. And also consider, we can't walk along this path either. So if we want to figure out the slope and we're looking at a line, at the equation of a line, it's sometimes easiest to identify if the line is written in a certain form. And this one is called slope-intercept form, where we have y equals a number times x plus b. That number is m. So anytime we have an equation written in this form, this is called slope-intercept form. And we can look at the number that's in front of x, and that tells us what our slope is. So in this equation, the slope is 3, or 3 over 1. Rise 3 over 1. In this case, the slope is 3/8. So up 3 over 8, up 3 over 8. Rise over run. B in this in this equation form is where the line crosses the y-intercept. So the line goes through the y-axis at positive 1/4. On this equation, the line crosses through the y-axis at -4. What is the slope and what is the y-intercept of this line? So let's first rewrite it into slope-intercept form, and to do that we are rewriting it so we have y equals. So we need to reorganize this equation to solve for y so that we have now y equals, here's our slope and here's our y-intercept. Find the equation of a line. So if this is our slope and this is our y-intercept, all we need to do is start with our formula, our equation, replace m with our slope and b with our y-intercept, and there's our equation. Graph the equation, graph a line with the slope and y-intercept. So all we need to do is find the point first. Graph your point, 0, not going left or right, 2, positive 2, up 2, make my point. Now my slope is negative 3, 2, so this means I'm going, remember the first one is rise over run, so am I going up or down? I'm going down because it's negative, 1, 2, 3, and positive 2 over 2. Down 2, 3 over 2. I could continue and continue, and this line would continue to go in a negative direction. Okay. If I accidentally went down 3 and over 2, down 3 and over 2, then my line would be positive, and I know that's not right because the slope is negative. So if I accidentally did the wrong direction, I can check my work by seeing which direction that line is going. Parallel lines, we're looking at straight lines that never intersect, never touch. They have the same slope, but they just have a different y-intercept. So, here it might be crossing at -1, and this y-intercept is -2. Perpendicular lines are lines that meet or intersect at a 90-degree or right angle. They have slopes whose product equals -1. So these are just some interesting facts that can be helpful. So if I multiply the slope of this line 1, multiply it by the slope of line 2, I end up with a value of -1 every single time as long as those lines intersect at a 90-degree angle. So here's an example. Line C has a slope of 1/2. If line D is parallel like railroad tracks to line C, what is the slope? And since they're parallel, they have the same slope. So it'd also be 1/2 because they're increasing at the same speed. That's what our slope is. Rise over run. What if they're perpendicular? Well, I'd have to think of what number times 1/2 would equal -1. And that would have to be -2. -2 times 1/2 equals -1. And that concludes section 7.3.